So today we'll learn about the circular header and header lists. Also we'll learn about the linked stacks and queues. So we are discussing the circular list basically on a singly linked list. So that is why we have one data field and one this is one data field and one link field. Okay, one link field. So what is this concept of circular list? The circular list is nothing but we are always in a circular list will have a node. Okay, we'll have a node of this one node. This is basically it's a singly linked list we are speaking about. We have a dead node and we connect its link to the beginning. Okay, beginning of it, that's all. Okay, so if you have say more than one node, if you have say one more than one node, then we can understand it better. So what I can do is nothing but say I have one more node of 20, so link will be in this way. So what do you mean by a circular list? So when I have instead of pointing the 20's link field to the null, what I do is nothing but I point the 20's link field to the first node. Okay, so that is what I am doing here, that's all. This is becomes a circular list. So this thing is called as a circular list. Okay, so this is about the concept of circular list. Now let us understand about the operations which they what they are doing on the circular list. So four kinds of operations are shown here on a circular list. So let us see what operations they are doing. So the four operations are nothing but, so if you go to the A, okay, if you go to the A, they have a list over here with three nodes having data 10, 20 and 30, and first pointer and last pointer, of course they are pointing to its right places. Then last pointer is there. No, so if the last pointer of the next of the last pointer we are we are pointing it to the first, so that makes it circular. So what I am doing is nothing but I am deleting 30. So if you see students, I am deleting 30 means 30 is at the end. So what I am doing is nothing but I just delete 30 and yes, I join the link basically, or the node which is previous to 30. Okay, we begin join it to the first. So that is what we do. So when we do this, it becomes delete. Yeah, 30 is deleted. 30 is deleted. Yes. And next one is exactly the other way around. That is nothing but yes. So the 20 is there. Okay, 20 is there. We are inserting one more node at the end. Insertion at the end. Okay, so 40 is inserted here. Okay, so how do we do that? Basically 20 is next pointer which is pointing to the beginning. We make it point to the temp, and the temp's end we make it to point to the beginning. So that is how we insert 40 at end. So these two cases, that are A and B, are nothing but deletion and insertion at end. Insertion at end. So next two cases, what we deletion and insertion at beginning. Deletion and insertion at beginning. Okay, yes. So in the C, that is third case, what I am doing is nothing but I have 10 at the beginning. What I do is nothing but I delete the 10. Okay, I delete 10. Okay, and what I make is 40, which is the last node. I make it to point to the next of first node. So how do we do that, students? Of course we move this first, which is there in the 10 to 20, and we delete. So that is how we do it. Yes, so first we move this first, okay, new first. Then what we do is nothing but last pointer we maybe make it point to the next of the previous first node. Okay, yes. So that is how we do it. Okay, next is nothing but insert 50 at the front. Insert 50 at the front. So what we do is we get 50 and we insert it at the beginning. Okay, in the same fashion. So this is insert at beginning case. What we insert 50. So this previous one was delete at beginning. So let us see the insertion code for a circular list. Let us see the insertion code for a circular list. So this is a insertion code for a circular list. Okay, so let us create, or let us do the circular list here. Well, of course, to create a circular list, we have a function called as insert. Yeah, this is a user-defined function. You can once again, you can give your own the function there, user-defined function. Okay. Yes. So I need T, that is for traversal as usual. Okay, and temp is a node for creation, new node creation. You can tell new node creation, and this is for memory allocation for a node, memory allocation for a node. Okay, next I display message, then I write display data. So fill data to a new node or new node. So here it's a temp node, new or temp node. Okay, so when I do this, of course, say I already have a list here. Okay, for the uh, simplicity. Okay, one more node I'm adding. Okay, yeah, one two I have two list of two elements. So here temp is there. Okay, say temp is there. Yes. So what is the value? So this is now not how it is. This is how it is. Temp. I add some data 30. Okay. Yes. So what I do is nothing but I make t point to first. So we know that this is first. Okay. This is first. Just a second. Yes. So we know that this is first. So even t will point here. So what if if first is not is equal to null? Yes. So we know that it is not. Oh, sorry, students. We are speaking about the singly linked list here. Okay. So we'll only have here. Yes. Let me show this example again for you. We already have a node here. Okay. Let me do it for again for you. Okay. So 10 and 20. Yes. Now it is correct. Okay. Yeah. So this is not a doubly linked list. So we are not speaking about the doubly linked list there over there. Okay, we should be a little careful there. 10. Yeah, now it is correct. So what we do is nothing but say t we are making it to point to the first node. So if first is not equal to null, so we know that it is not is equal to null. Okay, so it will be like this. No, it will be is equal to null. So if first is not is equal to null, what we are supposed to do is nothing but while t of link not is equal to null, till t reaches end, till t reaches end, students, we have to go. So we have to traverse. What we are supposed to do is we have to do t is equal to t of link. So traverse till end, traverse till end. Okay, traverse till end. So we do t is equal to t of link. So t which was there here gets cancelled from here and it reaches here. Okay, so here what happens is nothing but here what happens nothing but t becomes t will it becomes, yeah, t of link becomes equal to null here. Okay, here t of link becomes equal to null. So what I am supposed to do is nothing but I have to attach. Now here I am doing t of link is equal to temp. So when I do this, new node gets attached. New node gets attached. Okay. So this null what was there here in the diagram, that new link will be created. Now this is, we know that this is temp, no? So this will be attached now. Okay. Now students, but it is not circular in nature. So for that what I will do, students, remember here, once if executes, what you're supposed to do is you have to execute this code. So students, just I mean for your information, this temp is equal to temp of link is equal to first, which is inside else. It is not inside else. So remember, it should be here. Okay, because once if for if and else cases both, you need this step, that is temp of link is equal to first. That is nothing but you are connecting the temporary node to the first node. That makes it circular. Okay, you are making it, that makes it circular. Okay, so when you do temp of link is equal to first, this link will be created. Okay, this link is going to be created. Okay, so this is nothing but temp of link is equal to first. Okay, yeah. So this is nothing but case one, students. Case one, if. Okay, whatever you are understood. Now next, students, what we are supposed to do is nothing but say if first is equal to null. Okay, if first is equal to null. So now let us go with the next case. Now let us go with the next case. Okay. Yeah, so we have to delete all those things now, all these things, and let us go with the first case. So according to the case 2, what we are doing here, here it is nothing but here the t of link is equal to null. So the case 2 is nothing but t of link is equal to null. Sorry, not t of link is equal to null. Here it is nothing but first is equal to null. First is equal to null. So which is nothing but else case. Else case. Here it what we will have is nothing but here only one node will be there. Okay, one node will be there. Say 10 is there, and it is only first, and of course it is next will be null. So that is our condition. That is first is equal to null. Okay. So if first is equal to null, students, then if fails, then LP enters F. What you are supposed to do is first is equal to M. Okay, so that is the case. So temp students, see students, this is temp. Okay, so temp only will be the first. That is the one step. Next is nothing but what you are doing is nothing but temp of link is equal to first. That you are doing. So of course this will not be here. It should be at the end. So when you do that, this null, whichever is there here, okay, that gets connected like this. In else case. Okay, again I'll tell you. So students, how do we create a node? How do we create a node? We create using temp. So when you create that, what will happen? See else case once again in detail. So you create a node this way. Okay. So this will be temp. Okay, it will be 10. So this we know that it is an else case. So of course first also will point here. Okay, then final step temp of link is equal to first. When you do that, both it will connect this way. So that is the else case. That is about the concept of the circular linked list insertions. That is the concept of the circular linked list insertion. Okay, yes. So let us go to our next one. So this is the deletion, students. Circular linked list insertion is over. Now let us understand about the deletion. So of course we should have some list over here for our understanding. So let me have some this thing 20. So this is of course a circular linked list. So it should point like this. Correct? No? Yes. Here also we know that this is first. So here we are taking two nodes for traversing. So we know that whenever we delete, we take two things, that is pre and t into consideration. For moment we use two things. So t first I take, students. Okay, that is t is equal to first. So both will point same. T first is not is equal to null, students. Yes, it is not is equal to null. What we are supposed to do is nothing but yes, first is not is equal to null means we have more than one node. As simple as that. So while t of link not is equal to first. Okay, so till t of link becomes equal to first, what we are supposed to do is nothing but we have to execute these two steps till t of link becomes equal to first. Okay, so what I am doing is nothing but pre is equal to t. So pre will also point here in the first iteration. Pre is equal to t. Pre t. Okay, then t is equal to t of link. So t which was there here, which gets yeah, t which was there here gets cancelled from here, and t comes here. T comes here. So this is first. Okay, and pre is here. Pre and t. Okay. Then students, that is how it goes. So always pre with pointer will be one step below, one step behind t due to this. Okay. So this is nothing but traversal of pre and t pointers. Traversal of preview and t pointers, as simple as that. So when students, in this case, see now your case is that is nothing but t of link becomes equal to first in this case. Okay, now so that time what happens, these steps will not execute. Okay, it will go directly and execute this p of link is equal to first. So now we students, we know that previous here, which is pre of link, this one. So we are deleting here, so we don't want this node. What do we do? Nothing but from here only we take it and we connect it to this. Okay, so when you do that, of course this t will be deleted, students. Okay, so we should know which node is deleted. Okay, so for that this t is there. Okay, for showing deleted node data, for show deleted node data, and this one is for deletion of last node. Okay, last node. Else what will happen, students? Else means it will not have any elements, as simple as that. Okay, so that is how our node gets deleted. Okay, students. Yes. So when we do pre of link is equal to first, this is how it gets connected. Okay, I will just show you again. That's all. Okay, same. So that is how your deletion works. So where always remember, whenever deletion is there, you need two pointers, pre and t. And pre pointer will be one step behind the t, and t you exactly is the one which you are deleting. Okay. So for displaying which data has got deleted, you need t of data. So as simple as that. So this is about the circular linked list deletion process. That is nothing but header linked list. So students, in header linked list, you have two things. One is grounded header linked list. Another one is nothing but circular header linked list. So let us see what are those. Okay. So header linked list is a special type of linked list which contains a header node at the beginning of the list. So students, we observe here you have one special node, students. In both case A and B, you have one special node. That special node is called as a header node. Okay. Yes. So this will have the information about the first node here. Okay, and it will start linked list will start from there. Okay. So here two types are there. One is grounded header linked list. So this grounded header linked list which stores the null in the next field of the last pointer. So we know that students here 6 is last. So it will store the null pointer at the last. That is about the grounded header linked list. Another one is nothing but circular header linked list. Circular header linked list, students, what it will do is last node, last's next pointer. This is nothing but last's next pointer will be stored to the, yeah, will be pointer will be connected to head, will be connected to head. Okay, that is about the header linked list. That's all. Okay. Yes. So let us see the properties, students, properties and algorithms. So we have already seen the we have already seen the code for the just circular list. This is the algorithm for the circular header list, students, which you have just learned. Okay. So let us see the steps there. Null pointer is not used. Okay, and hence all pointer contains valid address here. Remember, student. Okay, every node has predecessor. So the first node may not require special case. Okay. First pointer, set pointer is equal to link start. Okay, set pointer is equal to link start. So that's what we have seen. Then you need to apply the step 3 and 4. Okay, till pointer is not is equal to first, because it is circular in nature, students. Because it is circular in nature. So of course here it is nothing but pointer will be equal to first start here. Okay, last pointer. So that is how it is. Okay. Yes. So here, students, let us continue. Yeah, you need to repeat step 3 and 4. What is step 3? Apply process to info of pointer. So you need to go, put information here. Okay. So this is nothing but, students, putting information here. Okay, let me take some other ink. Yes, here is nothing but fill data into list. Fill data into the list. Yes. And this is nothing but set pointer is equal to link of pointer. This is nothing but progress. Okay, to progress in the list. You need to do that. So when you need to do that till pointer is not is equal to start. Okay, once you are done, you need to exit. So that is about the algorithmic part of the circular header list. Yes. So what is push and pop, students? Basically push is nothing but, yeah, now we are speaking about the linked stacks. Okay, in the stacks, which is nothing but stack concepts implemented in a list, entered in a list. So we have two concepts there. One is push and another one is pop. One is push, another one is pop. So here we are speaking about only the push. Okay. Yes. So this is the stack, students. Remember, if you have forgotten till now, in stack it is nothing but always the LIFO concept is I mean, LIFO concept is followed, which is nothing but last in, first out. Last in, first out. Okay, what do you mean by that? Whichever element we put at the last, that element we remove it first. Okay, so if you take this one, students, so see, you can see case A and case B. Now if I take this for case A we are implementing it in a list, students. Remember, we are implementing it in a list, and we know that top will always store the top will be there at the top toppest position. It will be there at the toppest position, and top will be removed first. Okay, so here see students, one is at the top in this case. Okay, so we when we enter one more element 9, it will be coming to here. Okay, and I mean above one it will come above one, then we need to update the top pointer. That is how your push concept works. Okay, so how this will be stored, students, in the stack. So if you draw here, line 5 will be stored at the beginning, then 6 will be stored at the beginning, then 2 will be stored, then 4 will be stored, then 3 will be stored, then 7 will be stored, then 1 will be stored, then 1 will be stored, and here it will be top. And what will happen when you come to the case B? What will happen when you come to the case B? Okay, when you come to the case B, what will happen? One more element will come 9. Okay, and your the new top which was here, you need to update that. You need to update this top. Okay, top. You need to update. So this is how your push works. Linked stacks push works. So let us see the steps now of that. So you need to allocate. Step one is nothing algorithm for a linked stack push operation. So it is nothing but in step one you allocate memory. You allocate memory for the new node and name it as the new node. Okay, so memory allocation for the new node, you name it as new node. Okay, so that is the first step what you have to do here. Okay, what is the step two then? In step two you have to set new node of data is equal to val. That is nothing but in new node, in the new node. So see, you will create new node first. Okay, say that new node is the data you're filling. So this is val, whichever is val. Okay, val of a new node. Okay, that you're filling. So if top is equal to null, students. So this is the case. This is the case if you don't have anything in stack. If top is equal to null. If stack is empty. If stack is empty. If that is the case, what you do? New node of next is equal to null. Okay, new node of next is equal to null. You do, students. Okay, so this is the new node. It's null. Yeah. Okay, so if you take this as a new node of next you is a null. Then what you do is top is equal to new node. So you make top point here. So this is nothing but case one. Now what happens in the case 2? What happens in the case 2? That we'll see. That is the else part. So there what you're supposed to do is set new node of next is equal to top. So have you will already have one node. So that becomes new node. Okay, so when new node is here, of course your new node will not be here. So you put new node here. So let me put a value for that, say 20. The new node of next is this field that you are connecting. New node of next that you are connecting. Okay, and top which is here, now your top is updated, students. It came here, correct? No, so top which was there here in case 2, that will come here. Now that is the first node, so your top will be here. Yes, we are already successfully inserted the 20. Okay, that is new node. So that is how your algorithm works. So this is end of if and this is end of your algorithm. This is how your linked stack push operation works. Linked stack push operation works. So whatever we used to show it this way, okay, we have shown it in this way. That is nothing but in link. Okay, stacks shown in linked list. Okay, yes. So next one is nothing but okay. So see usually how it will be like this, it will be correct, no? Yes. So this is the normal way. This is the linked list way. Okay. Yes. So next we'll go to the linked stacks pop. Now this is the linked stacks pop operation. What is mean by pop, students? Pop means remove an element from top. Remove an element from top. Okay. Yes. So here, so if you take it in a normal way, how it will be stored, students? This is how it will be stored. Correct, no? You have 9 1. Oh, sorry, not 9. We have to start from below, correct? No, so it will be nothing but, yeah, it will be nothing but 5 6. Okay, 5 6 2. So A we are showing now 5 6 2 4 3, 7, 1 and 9. Okay, now this is the top. Okay, now pop means what, students? Pop means you have to remove this element and you need to update top here. Okay, you need to update the top there. So this is what we are doing. Now that is the case B. Okay, that is the case B. Because topest element will be deleted. Topest element will be deleted. Okay, yes. So this is the case B. So that is what we are supposed to do here. Let us see the same operation via code. Okay, yes. So first is nothing but first step is nothing if top is equal to null. So students say if I have a stack like this, yeah, if I have a stack like this, okay, nothing is there. Top is not pointing anywhere. Okay, say if top is not pointing anywhere, so that means what, top is null. Correct. Now then it is underflow. You cannot delete underflow. Cannot delete. Delete, not delete. Pop is the right word because we are speaking about the stacks now, so you cannot delete. Once again, okay, you cannot pop. Delete and pop same thing, students, but we have to use the right words in that step. Then you need to go to step 5, that is end. Okay, but if that is not the case, say I have some elements here 3, 2, okay, and 1. Okay, say one simple example I'm taking for you, and we know that this is top. No, in this case, okay, else case. Okay, this is the else case. What we are doing is set pointer is equal to top. So pointer will also be here, students. Both pointer is equal to top, then top is equal to top of next. Top is equal to top of next. So top will move here. Top will move here. So that is how I delete this. Okay, why pointer, students? Because if you need to display that, then that cases you need what was there in first, what was deleted to display. That is why you need pointer. Then you need to free the pointer. Then you need to free the pointer. So that is how it works. Okay, so if I show it in a linked list means say it will be like this 3 to 1 I told you 3, this will be null and no 2, and it will be 1. Yes, okay, now 1 I'm deleting, say I'm deleting 1. No, okay, say this is top. Now when I do top is equal to, yeah, top pointer is equal to top, so of course pointer will also point here, and top is top of next, top will go here. So how it is shown, top is shown like this, top. Okay, so how does it, how does top go here? Top, when I do top is equal to top of next. When I do top of next, top goes to next element. Top goes to next element. Okay, then you need to free pointer. Then you need to free pointer. So when you yes, when you free pointer, top link will be, yes, pointer link, which is nothing. The pointer node, you can tell pointer node. That is the previous top node will be deleted. Previous top node will be deleted. Okay, you can also display before you free the pointer. You can also display things. That's also possible. So that is about the pop operation. So when you do that, this will be deleted. This will be deleted, and this is your updated one. Okay, so updated stack, updated after deletion. Okay, so that is about your algorithm for linked stacks pop operation. Yes, so we are done with our stack, students. Now let us speak about the linked queue. How do you insert? So queue, students, it is other way. It is we always insert at the rear end and we always delete at the front end. Okay, queue means what? Delete from first, delete from front, and insert from rear. Okay. So here the 5 will get updated. So after you put a new element, after may you come, I mean from after you put a new element, it will update here at the rear. So update element at rear when the new element comes. When the new element comes. Okay, here go out, go out from front, out from front. Okay, so that is the linked representation of a queue. Okay, so in a this is the linked representation of a queue. So how does a queue, students, if you take this way, the queue, how will it be stored? 1 7 3 4 2 6 5. This is how it stores, correct? No, where this is a rear end, this is a front end, and here you go out. This is our queues. Okay, queues. So let us see how do you insert now. Okay, so this operation is taught insertion. Okay, newly inserted element. You see the code for that. So what are you doing here? Allocate pointer for the new node and name it as pointer. Okay, so you need to memory allocate for the new node. One new node will be there, students, which we are speaking about insert here. So let me put 10 here. Okay, and this is pointer. Now I know this is pointer. Okay, and I have already one in queue here. Okay, so which is inserted in linked list, say 20 and 30. Okay, so we know that this is front, this is front, and this is rear. So we need to insert behind this. Remember pointer. What I do? Set pointer of data is equal to val. So inserting value to new node. Okay. Next, if front is equal to null, students. We are not speaking about this case. Okay. What we are speaking about else case. So whatever we are doing, rar of next is equal to pointer. So this is rar. Which is rar of next? So this. When you do this, this will be coming. So which what is this? Rar of next is equal to pointer. Next, set rar is equal to point. Now students, when we do this, one more one more last node will be created. So rar which was here will be cancelled from here, and the rar will come here. Okay, so rar here. So make or move rar to end. Sorry, move rar to end. What is this? Connect previous rar, or we can tell rar. Okay, connect rar to new node. Node. Yes. Next, what you do, set rar of next is equal to null. Okay. So once you update here, students, what you do is nothing but you make this as null. Okay. So successfully inserted. So in this case too, or else case. Okay, else case. So when this, yeah, new new rar next point to null, point to null. Okay, so this is the if next case. Now let us speak about the first case. That is, what if front is equal to null. Now when is for a front is equal to null, students? That is, front is equal to null. So that is nothing but if case. So we need to delete all these things. Correct? No? We need to delete all these things. Yes. Okay. Yeah. Now let us speak about this. If this is the one case one. That is if case. Okay, so front of next is equal to null. So we know that it is null. So how to do? Front is equal to null means what? Set front of rear, front is equal to rear is equal to pointer. Okay, front is equal to rear is equal to pointer. So both everything will be same now. Front, rear, pointer, all same. Remember, PTR. Then you do front of next is equal to rear of next is equal to null. Okay, rear is equal to next. So you are deleting, you are what you're doing is you're inserting, no, students. Okay, so here what you're doing is nothing but front is equal to rear is equal to pointer means, students, what you're doing is nothing but here your insertion is going on. When that step is executed, this front rear will point to, previously it was that way how I had shown, one new node. Now 10. Okay, front is equal to rear is equal to pointer, it will point like this. So that is how you insert. That is how you insert, because comes at the end, students. Remember, comes at the end and goes at the front. Okay, so that is how it works. Front is equal to rear is equal to pointer. So this is our pointer, remember. Then set front of next and rear of next is equal to null. Okay, yes. So that is how it works. That is about the linked queue insertions. Yes. So another this is about the linked queues insertions and also the deletions. Okay. So deletions means what will you do, students? What will you do? Deletions means that last you front whichever element is there in front, you delete front. Okay. Say if this is front, yeah. Say for example in the linked queue deletion, what you do? You delete from front. Okay. Delete from front. Delete from. Okay, so that is the thing. So if this is the case, this is your rear, you have 10 and 20 here, front is here, what you do is you delete this. So what you do make is front to next you move. Okay, you move the front, you update the front, that's all. You have to update the front. So front which was in here initially, that comes here, that comes here. Okay, now front rear will pointer, and of course we know that this itself is a pointer. Okay, yes. So, and this becomes the updated one, and we make this fronts next is as null. That's all. This is how you delete from the front. Okay, that's how you delete from the front. This is about the linked queue insertions and deletions. Okay. So if you want to show it in the normal case means, say if this is a queue, you have here 10, 20, 30, okay, 40, 50, and say this is front and this is rear. So of course it comes from here, students. We know, no, it comes from here. That is enter here. Say one new element will come 60. Now here deletion means go from out. So leave from here. Okay, leave from here. So this is about our queue deletions. Okay, so that's all we have, students. Okay, thank you.